Hello Vertex farmers, it's Crocodile Arms here, and in this video we're going to be talking about quadratic voting, getting into the nitty-gritties of the formulas. Quadratic voting is a style of voting that's used primarily to empower the democracy and reduce the power of unpopular votes so that the majority and plurality per wallet are the ruling factors more so than if you didn't apply this function. And it works to award the more popular choices. So in this table, we're going to get to it later, it adds voting power of 33% and it takes away from the unpopular choice by 20%. So it's kind of like it's like an unpopularity tax. And that's because the majority and plurality rule are expected to be the smarter choice. There's power in democracy, but there's also intelligence in democracy too. And that is no new idea. So we have to get to the bottom here to know your actual how it affects everything. You have to first calculate using this function here to get your what I'm calling your choice power in, which is all of the vote powers square rooted and then added together. So individually you take the square root of them and then you add them all together, as you see here. Vote power 1, so let's say that's my vote and that's your vote. You take the square root of them and you add them both and then you square them all together. So it's the sum of square roots squared. You take that number and you have to adjust it to make the math make sense at the end. Otherwise, this actually multiplies. A very interesting thing, by the way, about this is if there was only one vote, then the power in is the power out. But if you have more than one vote, then you have an increase in power. So that's, you're gonna have, if you have a lot of votes per choice, then you're gonna have a pretty enormous power at the end if you add up all the choice power ins. So you have to divide out the choice power ins, all of them, and multiply by the vote power initially to get the correct choice power in. This is so that your vote power is equal to your choice power outs. The sum of your vote powers equal the sum of the power outs. By the way, that little symbol means sum of. I don't know if you knew that. And this is so key to making the numbers look pretty, but also to getting the appropriate taxes at the end to understand, like, this money is going here. 20% of this went to that one to pump it up by 33%. Well, let's get into some of the math. By the way, let's call this function the correction factor, which we're labeling as f sub c. In choice 1, in this scenario, let's say one vote was worth 16 power, another one was worth 4. They both voted for choice 1, and that's a total of 20. Choice 2 had 3 votes. Each one was worth 4 power, and you get 12 at the end. So choice 1 would have won in this particular scenario with 20 voting power over the 12, even though less people voted for it. But when you actually do the math using the quadratic coin voting formula, you get that they're actually equal in the end, because the square root of 16 is 4. The square root of 4 is 2. You add those together, you get 6. You square that and you get 36. Multiply that by your correction factor, which is this 0.44 repeating 4s. That's 16. Now you do this on the same side with 3 square root of 4s to get the same 2 plus 2 plus 2 equals 6. 6 squared, 36. And you see now the formulas become identical after this point. So you end up with 16 at the end. Now, how to get that 0.44 repeating 4s is you took the 20 plus the 12, which is 32, and you divided that by the outputs here, 36 and 36, which is 72. 32 divided by 72 is 0.4 for repeating fours. And one of the things you can do to make sure that you're correct in your output voting power is you can add up the output voting powers and check it against the inputs. So 16 plus 16 must equal 20 plus 12. Input must equal output. And that's the case, because 16 plus 16 is 32, and so is 20 plus 12. Checks out. How you calculate who got the distribution and who got taxed. This one, definitely, negative 20%. So it only kept 80% of its initial voting power. 20 voting power got dropped down to 16. And those extra 4 voting power went to choice number 2 to make 12 into 16, which is a 33% increase in voting power distribution. So in the end, they ended up being a tie because one more person voted for this one, even though it got less voting power initially. That's quadratic coin voting, and this is Crocodile Arms.